All right, so here is your answer to the first problem on the 2D problems review. Um, if you take a look here, we have a force is applied to a 50 kilogram object. It's sitting on a level surface, and the force is being applied 35 degrees above the ground. So this is a force being applied at an angle. All right, so let's go ahead and just draw a quick sketch here. Right? The coefficient of friction is 0.25, and what is the magnitude of the force? Okay, well, the first thing we need to do here is we need to redraw this as a free body diagram that we can actually understand. So this will be our force, and we know that this force will have a component in the x direction and the y direction. And so let's actually draw this real quick. So we got our 50 kilograms. So we know what's actually pulling the thing is the Fx. We've got Fy. And we've got F norm. Sorry. That's supposed to say norm. So we know we have the force of friction. And then we've got the force of gravity. Okay. Now, we also know that our angle here is 35 degrees. So your first step is to find Fx and Fy, regardless of whether you can get an answer or not. So I'm going to do that real quick. So Fx is going to end up being F cosine 35, which ends up being, if we punch that into the calculator real quick, 0.819 times F. So this is 0.819 F. Okay. Now I'm going to find Fy. Fy is going to be F sine 35. And that's going to come out to be 0.574 times F. All right. Now, the reason this is important is because we're going to have to use this later to solve this problem. Now, when we start looking here, okay, we know a couple of things. We know that Fx is equal to Ff. Now, Fx is equal to 0.819 F. And we know that Ff is equal to F norm times mu. And so we've got to figure out what F norm is. Well, in this case, F norm is going to be equal to, if we take a look over here, I'm going to draw this in red so you can see it. Know that F norm is going to be equal to Fg minus Fy, because F norm and Fy adding up will equal Fg. So F norm is actually going to equal Fg minus Fy. All right. So if we come back down here and we plug that in for F norm, so this will be Fg minus Fy, that's F norm, times mu, all right? And all this is still equal to 0.819 F, okay? Now we've got to start plugging some stuff in. So Fg, the mass is 50. So if the mass is 50, Fg equals mg. 50 times 9.8 will give us 490. So this is 490 minus Fy, which we just figured out was 0.574 F. So 0.574 F times our coefficient of friction, which we come back up as 0.25. And that's equal to 0.819 F. All right. So now what we've done is we've substituted for everything. Now it's just a matter of doing the algebra correctly and making sure we get the right answer here. So I'm going to distribute my 0.25 through to my parentheses there. So 0.25 times 490 is 122.5 minus, and then 0.25 times 0.574 is 0.1435 times F, and this is equal to 0.891. Excuse me, I messed up there. End up with is 819 F.
Oh, okay. Can I try to draw?
So that you just heard my son, he's trying to help me out here. He needs to sit quietly and watch.
No, I'm not
drawing. All right, so I'm going to finish this up real quick.
Okay.
And Elias is going to help. All right, so now all we need to do is solve for F. So if we add 0.1435 F here, that will cancel. So we're going to add 143.5 F over here plus 0.819. We get 0.9625 F is equal to 122.5. Now we just divide.
Daddy?
And we get an answer of F is equal to 127.2 newtons, which we will round to 127 newtons.
Daddy?
So to summarize, all right, what you're going to do, redraw your free body diagram into something useful, find components. Once you find components, start plugging in values for what they're equal to, and then just start solving it down, and eventually you'll get to a point where you have one variable in one equation